forth, so it should be all right. All right, so the do now problem, we're looking at the graph. Axis of symmetry. Does anybody know what the axis of symmetry would be here? X equals 1, yeah. 1, negative 10 would be the what? Boom. Very good. All right, we need the intervals where the graph is increasing. All right, so that's where the slope is positive as you look at it from left to right. So where is it going uphill in terms of x only, though? 1 to positive infinity. All right, what about the fencing on that? Are we talking brackets or parentheses?
Bracket around the one, parentheses.
Very, very good. All right, so bracket 1 comma infinity. Now interval or intervals where the graph is decreasing. Negative infinity to 1. All right, bracket on the 1 though, right, as you said. All right, and how do we know that the infinity is getting parentheses? Because you can't equal infinity. You can't equal something that you can't actually capture. All right. All right, standard form of a quadratic. You know this from the last unit. Y equals ax squared plus bx plus c. The axis of symmetry formula, do you know that? No, that's new then. It's going to be x equals negative b over 2a. All right, so if the axis of symmetry is smack dab in the middle of the graph, you could always find it by taking the average of whatever your roots are. So if you were able to find the roots just by looking at the picture, and maybe for example, the axis of symmetry wasn't as obvious, then you could find your roots and just add them together and divide by 2, and you'll know your axis of symmetry. You wouldn't need a formula for that. But if you're dealing with just an equation and you don't want to create the graph, then using this formula is a really good resource. All right, now the vertex, the definition of a vertex, you talked about this last time, would be the turning point of the graph. Now you need the actual coordinates of the vertex. It's a little bit trickier. What you're doing is you're finding the axis of symmetry, so negative b over 2a, and then the y value that goes along with that. All right, so we would write this as f of negative b over 2a. All right, so this part, in terms of notation, it's really kind of funky looking. And actually, you look at the coordinates for the vertex, it looks like it's a foreign language. You're looking at really, again, just the y value for your axis of symmetry, your A of S. All right, so once you figure out your axis of symmetry, you plug it back into the original function and come up with the y value. Now, fortunately, you're allowed to use graphing calculators. So if that's the case, then you can just pop it right in. All right, so in the case of the first example, it's saying to do it algebraically, but there's no reason why you can't use your calculator to check. All right, so it's saying find the axis of symmetry and the vertex for each quadratic algebraically. It's a key word there. Very, very important. How much credit would you get on a test if you just wrote the axis of symmetry and the vertex without showing the algebra behind it? Half? All right, well, in my class, you wouldn't get anything, so it's nice. So it sounds like she's pretty generous with that. All right, but you didn't do it the way I wanted it, so I'm not giving you anything for it. So the idea of, if it's a multiple choice question, you're fine, obviously. So I'll show you the calculator approach after we do it algebraically. All right, so x equals negative b over 2a, so A of S. X equals negative b over 2a. All right, we know our model from the last unit because it's the same model that we used for the quadratic formula. So the a, b, and c values that you use to create the quadratic formula are the same a, b, and c values that you use anytime you're looking at a quadratic. All right, so negative something over 2 times something. What are my somethings? What's going on top? Negative b, so negative 4. Over 2 times a, what's the a? 1. So we're looking at x equals, what's negative 4 over 2?
Negative.
That would be if the 2 is on the top.
Oh, yeah, negative 2.
So negative 2. All right. So we have our axis of symmetry. X equals negative 2. Don't forget the x equals. All right, it's very important because axis of symmetry is defined as the vertical line that splits the parabola in half. All right, if it's a line, if it's the equation of a line, it has to be in the form of x equals some number. If you don't have the x equals, the scoring guide for the Regents exam, they tell us that we have to take off credit for that. It seems stupid. You did all the work to come up with the number. You might feel like you deserve full credit. They're not giving you full credit. So when we grade your tests, we can't give you full credit there either. All right. So, and be on the lookout for a trick question in the multiple choice. You know, I'm not an evil person, but when Miss Ingram and I sit down and create the test, we do try to make sure that you have the concept down. So one of the choices you can bet is going to say y equals negative 2. Another choice will say x equals negative 2. So it'll be testing whether or not you know that it's x equals that creates the axis of symmetry. All right, so be on the lookout for that sort of thing. All right, the vertex. We get that by taking that x value and popping it right back into the original function. So we're looking for y of negative 2. So into the original function we go. I'll just scoot that over. All right, so plugging and chugging away. Negative 2 squared is what? 4. 4 times negative 2, that's easy, right? Negative 8 minus 7. 4 minus 8 minus 7. Negative. All right. I always get hung up on the simple arithmetic. Negative 11. There it is. All right, so my vertex is x comma y, negative 2, negative 11. All right, so we needed our axis of symmetry and we needed our vertex, and now we have it. All right, let me just show you really quickly how you do that on the calculator. There's a couple of approaches. Yeah, I know, the screaming of the TV. That I think this was, oh yeah, no, there it is, 1977. That would be, let me see if I got the math down here. Yeah, that would be 5 years before I met Miss Ingram. We were in elementary school together back in the day. We've got a picture downstairs. If you ever stop by her desk, ask her to show you the picture. Class picture, we're right next to each other. It's the funniest thing. I didn't remember, but when I first got hired here, she was already working here. She came in, she walked right up to me and said, "I know you. We went to 3rd grade together." It was the craziest thing. All right, so hit y equals in your calculator. Type in, I'll try to get this off as quickly as possible so that the voices can leave you alone. So you're typing in your x squared plus 4x minus 7. You're going to go into your table, and then we're just going to kind of hunt around. But I'm going to show you 2 techniques. One is going to work when you have only clean numbers, and one is going to work all the time. Right? So you put your equation in, hit second graph, and what we want to do in our y column is we want to establish symmetry. So I want to move my cursor around until I have symmetry in the y column. All right, and what I mean by that is the top entry and the bottom entry should match each other, and the second from the top, second from the bottom, third from the top, third from the bottom, and so on. All right. Oh, okay, good. Now I was building up a little static electricity there. I usually get zapped. All right, so there we go. Look at that. See at the top and the bottom, it matches up perfectly. Second top, second bottom, and so on. Right smack in the middle That's your vertex. -2, -11. All right? Right in the middle, -2, -11. The x value of that is your axis of symmetry. Now you can see the significant drawback to this is if they're not clean values, it's not going to show up in the table. Right? So how do you get it if it's made up of not clean values? Well, the cool thing is we learn about this notation for a reason. The calculator understands this notation better than we do. Right? Its programming is based off of this notation. So you do the work to figure out your axis of symmetry, right? And let's say you come up with a fraction. This is what you do. Hit alpha, alpha trace. So you have a list of all the y's, y1 through y0. Alpha trace. Trace is right next to graph. Hit enter. Open a set of parentheses, and then type in -2 and close parentheses. Right? So the notation on the calculator, y1 of -2, that's what I wrote here. It's going to perform this operation for you. And it'll give you the -11. All right? So that'll work for any kind of function. So imagine a really complicated equation that's got a lot of disgusting decimals in it. You don't have to worry about the disgusting decimals anymore. It's going to do it all for you. All right? Yeah. Yeah, I can do that now. Sorry, I just needed to play that out a little bit longer. So anyway, if you figure out your axis of symmetry, for example, in number 2, and it all depends on the instructions, because if you have to show all the algebra, you got to show the algebra. There's no way around it. But in number 2, if I do my x equals -b over 2a, so axis of symmetry, -b over 2a, that's going to be 18 over 6, which is 3. So x equals 3. Now all I would have to do is figure out y of 3. All right, so you can't see it anymore, but you'll just take my word for it. In y equals, I would type in the original function, 3x squared, minus 18x plus 1. And then do that y1 of 3, right? So I'd hit alpha trace, y1 of 3, and hit enter, and you get -26. All right, so I now have my vertex, which is 3, -26. All right, so think of a multiple choice question on a test, for example. Not much work you have to do, right? It's pretty cool when you can think of it that way. And actually going forward, you know, you get to 12th grade, you got some complicated functions that you have to work with. This technique is going to bail you out on that. Is that the period?
Yeah.
Pretty much. All right. So you know what your homework is. Pages 6 to 8.
Yeah.